the fundamental theorem of algebra. Okay, the steps at the top are the easiest way to tackle this. It's not the only, but it's the easiest. Okay, using a graphing calculator to determine an easy spot to find x-intercepts. We're going to look at graphs, and if we can see where they're going across the x-axis, those are answers. So if the calculator wants to give us answers, we like that. If that doesn't give me all the answers, we're going to use synthetic division to get the expression closer, the polynomial closer to where we can get those answers. And then once we get down to a quadratic, remember a quadratic just means when x squared is our biggest degree. So like x squared plus 2x minus 7 or something like that. And then once we get there, we can factor. We can use the quadratic formula. Or we can solve by roots. We can just solve it like a regular equation and then just square root it at the end. Usually when we're doing this, the factoring or the solving by roots are going to be the easiest options. Now, if you like a one-stop shopping, I don't want to have to think about what option, if it factors, if it doesn't. I just want to be able to do the same thing every single time. You can use the quadratic formula, and I know it's been a little while since we've used it in here, so we'll make note of it just in case we decide we want to go that route. But I think once I show you the other options that we have and how much quicker they actually are, I think you're going to like them better. But I like to, bless you, I like to give you all the tools just in case you ever want to use them. So just a couple of notes here, and then we'll actually jump in and start doing some of these. Note, you will find the same number of solutions as the number of the degree. For example, in number 1, the largest degree is 3. There's going to be 3 answers. If the largest degree is 4, there's going to be 4 answers, and so on and so forth. And then the last little kind of note, even though we'll chat about it when we see one, if you graph the polynomial and the function seems to bounce off the x-axis. Now let me give you an example of what that would look like. So let's say I had something like this. Okay? So it comes down, it just barely bounces or kisses the x-axis and then goes back up. Okay? That means it's going to be what's called multiplicity, and we're actually going to count that number twice. Okay? So if you ever see the word multiplicity, it just means that answer is there multiple times. So like for instance on this one, let's say that was at x equals 2. If I was looking at zeros, I'd count that answer twice. I'm not doing that, because I made a mistake and meant to write something else. It just means 2 is going to be that answer. But we'll chat more about that when we see one. So how does this work? Oh boy. Find all zeros of the polynomial function. You must show work. Unless, here's the bailout. Unless you can get all your zeros on the calculator. It will happen sometimes. Not as often as you would like it to happen, but it will happen at times. So here's how this is going to work, especially for some of you that haven't used the calculator in a bit. So I'm going to try to get it where the calculator, all the necessary buttons are easily visible. Make this a little easier. So we're going to be in y equals. If there's stuff in your y equals, clear it out. And we're going to type in these polynomials. So, x, there's our x button if it's really been a while. Okay. Here is my caret button, my little up arrow that gets me my exponent, which I can then type in. Notice my cursor is still up in the exponent though. I've got a right arrow to get it back down to normal. There is a squared button, so if I get to squared, I can just hit that. And my 3x doesn't have one. I got to make sure my signs are right and my exponents are right. Otherwise, I'm not going to get the right zeros. So I'm going to take a look at the picture first. I'm going to be like, okay, there are going to be 3 answers. So what I'm hoping for when I look at the picture is that I see it's crossing at 3 spots, because that's going to make my life easier. All right. Okay. I see it's crossing here. I see it's crossing here. I see it's crossing here. So I can see that they're all 3 there. Now, if they're all 3 whole numbers, this is going to be the greatest thing ever. Well, how do I know? I hit second graph and I look at the table. Okay? What we're doing here is we're looking for where y equals 0, because that's what an x-intercept is. So, here's kind of our to-do list that we're going to be doing with these to make your life simple. I always would graph first and check the table, which is what we're doing right now. I visually saw 3 answers. Now I'm hoping they're all 3 going to be in my table. Well, when I get to the table, what am I looking for? I'm going to look for y equals 0. Because again, those are my x-intercepts. Those are my zeros. Those are my answers. And then if I find any of those, the x's are the answers, the zeros. And in this time, I'm super fortunate because I get exactly what I hope for. I start scrolling down, I'm like, ooh, there's a y equals 0. So x is 0. Ooh, there's another y equals 0. X is 1. And sweet. I got all 3 answers from the chart. This will not happen often enough for some of you, okay? It will happen some. Most of the time, though, I'm only going to get 1 or 2 answers from the chart. It won't be all of them, but it does happen. So I always want to do my due diligence and check that, okay? Sometimes I may be just given one of the answers. That's always nice, too, but that doesn't always happen either. So as we're taking a peek at these, okay, like I said, that was our best case scenario. Since that's not going to happen every time, we need to do one here that doesn't occur. So we're going to go back to y equals, and we're going to try this next one. Again, my up arrow button to get to my exponent, right arrow to get out. And again, between terms, I've got to use the minus sign that's on the right, not the negative that's at the bottom. That'll get you an error message. And so I go ahead, I punch that in, and I'm going to look at the picture first. So I'm just going to hit graph. I'm like, okay. This graph is so big. Now, I see there's 1. So let's see, at least if I get a little help here. Second graph. All right, big numbers, big numbers. Okay, there's my 1, 0, because everything else is not helping me. So I got x equals 1 from the calculator. But I need 3 answers. So how do I find the other 2? Well, here's how we're going to do this. We are now, it says up in step number 2, divide the original polynomial by the 0 that we have using synthetic division. Okay. That's the actual x. I don't change the sign like I do with long division, so I'm going to use the 1 in the box. I'm going to take a quick moment to make sure I don't have a degree gap. Again, a degree gap is, if this starts at 3, it should go down by 1 each time. 3, 2, 1, 0. So it does. I'm going to write down the coefficients. And for those of you that struggled a little bit with the division on the quiz, there's another chance to see it again at work, and hopefully that'll help you on a retake or help you here too. So I bring my first value down, whatever it is. I multiply that value by the value in the box. So 1 times 1 is 1, and I add down. Multiply 0 by the box. 0 times 1 is 0. Add down. 49 times 1 is 49. Add down. Whenever you do these, you have to get a 0 at the end. You should not be getting a remainder. If you did, something went wrong with your math somewhere. So once I get to this point, I plug my variables back in. Okay, I started at 3. I start 1 less than that. So x squared, x, constant, and my remainder. You're like, okay, so how's that tell me an answer? it doesn't quite there, but we're almost there. I'm going to write this out as the equation that's there. So x squared minus 49. Because 0x is just gone. So now I have to make a choice. How am I going to factor this? Am I going to, maybe it's on my chart, and I'm wondering, hey, they're both squares. Maybe it's a difference of squares. Oh, wait a minute, that's a plus. Notice there's no such thing as a sum of squares. Okay, so that's not going to work. I could plug it into the quadratic formula, but I think the easiest way is just to solve it like an equation. So if I'm going to do that, I want to get x squared alone. Okay, well, how do I do that? I get the plus 49 out of there. I minus 49. And now is going to become the moment of truth. How much do we remember from all the stuff that we've been doing? So, well, first things first, what's the opposite of squaring something? Square rooting it. So that tells me a couple of things. First, square rooting means there's two answers here because it's a quadratic. So I have plus minus. Then I've got to remember, when I'm taking the square root of a negative number, if I try doing that in my calculator, I get a problem. If I do the square root of negative 49, it says error, non-real answer, because you can't take the square root of a negative. How do I get the negative out? Take an I out. So, then I get fortunate, though, because 49 is a perfect square. Square root of 49 is 7i. One answer. 2, 3 answers. 3 answers, 3 answers. I'm good. Okay? That's the process that we're going to be working through with these. This is more likely to happen to you than this is. Even though this will happen sometimes, I want you to be aware of what could be the case. So, okay. Only way to get better, I've said this a lot, is to kind of keep practicing. So we got a couple more here we're going to play with. So I'm going to get my expression typed in. Again, keep right arrowing after these, because otherwise you're going to get a whole lot of stuff in your exponent that you don't want. Double and triple check to make sure your signs are good and your exponents are right. Okay, feeling good. I'll take a look at the picture first, because let's see if I'm going to have to do some work or if the graph's going to help me. Ooh, this looks promising. 1 0, 2 zeros, 3 zeros, 4 zeros. I need 4 answers. I think this is going to work out nice again, but let's check. Second graph. And we are on the lookout for y equals 0. Every time we see one, we do a little happy dance, either really or in our head at least. So negative 3 is a 0, negative 2 is a 0, negative 1 is a 0, and 1 is a 0. 4 answers. Woo! Okay. So again, we rejoice when that happens, but that's not going to happen every single time. We have to work around it. No. That'll be interesting on video later. They're going to be like, what's he going no for? Okay. So, guaranteed just about. You're like, yeah, we know Harty well enough. Guaranteed at this point. This one's probably not going to turn out as nice as the last one did. So, we got to take the good with the bad here sometimes. And I've mentioned before, even if you don't have one of physically these with you somewhere, we get some class time to do it, and also those apps I've mentioned for your phones and stuff before will do the stuff that you need. Sometimes they're even better. The one for the iPhone finds zeros better than it's easier to find on here even. So, okay. So let's see how much help we're going to get. A little bit. Okay. Looks like I'm going to get 2 zeros out of this. Let's see what we get. There's 1. Oh, there's the other one. Okay. So I get negative 5 and negative 1. But I need 4 answers. I only got 2. This one's going to take a little more work. So we may need to take a little bit of the room over here. So I'm going to box this off a little bit. So you're like, okay, how's this work? Because like up in number 2, we had 1x, we did synthetic division. How do I know which one to use? It doesn't matter. Really? No, it doesn't matter. Because we're probably going to end up having to use both of them anyway. So here's what we're going to do. I'm just going to use -5 since it happens to be here first. And I'm going to write kind of small. I would suggest you do the same because we may have some things to do. 4, 3, 2, 1, 0. At least there's no gaps. So I write my coefficients in. And I start my synthetic division process, which again is just pull down your first term, multiply it by what's in the box, add down, whatever answer you get, multiply it by what's in the box, that goes in the next spot, add down, just keep right on rolling. 9 times -5 is -45, add down. 9 times -5 is -45, and I get the all-important 0 at the end. So when I go to fill my variables back in, again, it's 1 less than the one I started with. So I started with x to the 4th. So x to the 3rd, x squared, x, and 9. Now, technically here, I could factor by grouping to try and get my zeros that way. I wouldn't suggest it just because if you stick to the plan above, we're less likely to make errors. So you're like, wait, does this mean I got to do synthetic division again? Because up here it says, repeat the steps until it's a quadratic, until it's x squared. This isn't x squared yet. You would be correct, which is why I said it didn't matter what order we did them in. Because now, I'm going to take the -1, and I'm going to do the division with the one I just got. Okay, so this is now the one I'm dividing in. Don't go back to the beginning. The one that we just did. So I'm going to use those coefficients. And we're going to run the process one last time. I promise we will not be doing it more than one more time. So bring my first term down. Multiply it by what's in the box. Add down. Multiply by what's in the box. Add down. Multiply by what's in the box. This better be 0. And it is. So I get here, and again, it's based on the one right above it, which was x to the 3rd. We start one less. X squared, x. And now it's going to act more like number 2 did. So I'm going to take this, which is x squared plus 9 equals 0. Because again, 0x doesn't do anything for me. It just kind of disappears. And I'm going to solve it the way I did the other one. So I want x squared alone. Get my 9 out of there. Take my square root, because that's how I get rid of the squared. And as long as I remember my plus minus, and to pull an I out, because the square root of 9 is 3, 2 answers, and 2 answers is 4 answers. This is as bad as it gets. Okay, number 4 is as nasty as we're getting. So if you can survive that, you're good. And if not, we'll get you to the point that you can, if we practice a little. That's the main focus of today. Now, there is one more thing we're going to take a peek at, which we're going to see more of tomorrow. And that is, and we've done this a lot in here, we tend to do something and then we tend to undo it, or be able to do it start to finish and then go backwards. That's what we're going to be doing on the back here. So writing a polynomial function. Write the polynomial function of least degree that has the given zeros and a leading coefficient of 1. So what we're going to do is, they're giving us the answers we're going to turn it back into the original problem. So how's that work? Okay, what we're going to just basically do is we're going to switch signs and turn these all into binomials. Okay, so that's parentheses with two terms. So in this first one, I'm going to show you where it comes from. And then once we see that, we can kind of shorten the process up a little bit. But when we have zeros of 2, 1, and 4, okay, what we realize is, okay, my answers were x equals 2, x equals 1, and x equals 4. So now I'm going to think back a step from that. So what that would mean is my parentheses that I had before that would have been x minus 2. Well, why? Because if I would have had x minus 2 equals 0, there's the x equals 2. That's the binomial it represents. And so I'm going to do that on all of these. And this is where the switch signs part comes into play. Thank you. Because basically all I did to get the binomials was positive 2 became negative 2, positive 1 became negative 1, positive 4 became negative 4. So my job then is I need to multiply this stuff out. So suggestion, well really there's no other option, we're going to take two sets of parentheses at a time, and we're going to box or FOIL them out. Now, I'm going to keep stressing this, and I'm not ashamed to keep saying that I'm going to keep stressing it this way. I am a bigger fan of the box because a lot of you, if you don't do the box, you do the first terms, you do the last terms, and you think you're done. I'll see a lot of x squared plus 2s on quizzes, and I'm like, nope, you've lost 2 of your terms. By doing the box and filling it in, I'm not going to lose them. So when I go to do this, I'm going to add my exponents if both my terms have them. Okay, even if you want to put the 1s in front, so when we multiply our coefficients, we can do that. So multiply coefficients, add exponents if you have them to fill in the box. Again, we're multiplying. Once the box is full, though, we're not multiplying anymore. Now I'm just going to go through and combine like terms, which just means we're adding and subtracting coefficients. Notice I didn't turn that into x squared. Negative 2 and negative 1 gives me negative 3. Okay, so this is my first two terms boxed out. But I haven't used this yet. So I got one more box. This goes along my longer side. And then the one that I haven't used yet goes along my shorter side. Nice thing about boxes, they can any size we want. Multiply my coefficients. Add my exponents. Multiply coefficients. Add exponents. Multiply coefficients, because that time I only had one variable term. And I do this all the way through, being very careful with my signs. Because nothing worse than to do all this work and then mess up a sign here and there and have it all go up. And so once I filled in my box, my like terms are kind of organized in the diagonals. I start with the largest degree. And again, we're just adding up the coefficients. Don't mess with the exponents anymore. And that would be my original polynomial function. If I were to type this into my calculator and look at the graph, the three answers would be at 2, 1, and 4. Okay? I don't have to check that, but it's just kind of lets you see how that works. Now, number 6, I'm not going to do the whole thing. I just want to make sure we can get them into the correct binomials. So I look at this and I go, okay, opposite signs. So opposite of negative 2 is positive 2. Opposite of negative 4 is positive 4. Opposite of negative 7 is positive 7. And then I would multiply this out like we did in number 5. Little box, then a big box. I still have not found a way to do a 3D box and have it all done in one step. So it's going to take some patience, it's going to take some detail work. And that's where a lot of our biggest struggles tend to come from. Okay, one twist to these. And that's what these last two are going to discuss. We're going to do number 8. I'm going to talk about number 7 then, but we're still going to do 8. Okay, so zeros of negative 5 and 2i. Okay, we've seen before, i's can be answers, so that makes sense. Note, imaginary solutions can come in complex conjugate pairs. Woo, what does that mean? That means that whenever you get an I as one of your zeros, it's assumed its negative counterpart is also one of your zeros, but they're not going to tell you. So whenever we see I as a 0, you take the opposite. So like on number 7, it says I as a 0. We're assuming negative I is also a 0. It just comes along for the party. So with that in mind, we're going to take a peek at number 8. Now that we know that there's 1, 2, 3 answers, even though we only looked like 2, I'm going to do my opposites. So x plus 5, x minus 2i, opposite of positive, and x plus 2i, opposite of negative 2i. And we're going to multiply these out like we did the one up above with boxes. However, okay, word of advice to make it simpler. When i's are involved, do the i's first, because the i's will go bye-bye then and make life easier rather than harder. So, I get my first box rolling here. I'm like x minus 2i, x plus 2i. So I start to multiply these. This is going to look weird. I'm like, okay, x squared, add my exponents. Well, what about the next one? Negative 2i and x. Exactly what you see, you write. Negative 2ix. And positive 2ix. And negative 4i squared, because we still treat the I like it's a variable, and we're going to add the exponents. So, two things to take note of here. As I start to put this together, I get to my like terms, positive 2ix and negative 2ix. Cancel. That'll happen every time. But when I get to here, I got one more thing with my i's I got to remember. What's I squared equal? Negative 1. So since I squared equals negative 1, this is really negative 4 times negative 1. So this is really positive 4. All the i's are gone. Okay. That's what I get out of my first pair, where the i's are at. So now that I've done that, I got one left to do. So I'm going to do one more box. The x squared plus 4 in one of them. I'll even label them here so we can kind of keep this straight. And then my x plus 5. So last box, still going to add my exponents. Still going to multiply my coefficients. Now a funny thing happens on this one. We're so used to something combining for like terms here, but we don't have any like terms to combine. X to the third, x to the second, x to the first, and 20. There's nothing to play with. So I just go ahead and write them in degree order. And call it done. And again, if I were to punch that into my calculator, the negative 5 is the only answer I'm going to be able to see, which also tells me when the i's are going to occur. So here's how we're going to do this on day 1 of this. Originally, when I first printed these off, normally I'm good about putting what the assignment is. And they're like, well, we didn't pick up a worksheet on the way in, so it must not be a worksheet. It's not. It is the infamous, monstrous 5-problem book assignment. Okay? Take out a camera, take out a book, and click pictures. Okay? Or, now this would be extreme. Okay? I don't think this might be the brightest idea ever, but, or, if you're watching this later, they're like, really, Harty, you're gonna hit pause, and you can look at the numbers here. And I'll actually hit pause in a minute and let you look at them. Yes, I'm that crazy, and I'll do whatever I need to get you to do the bookwork. Okay, there's going to be 31. I'm going to freeze the other one here in a moment for people in attendance. For those of you at home, do the practice. There will be a worksheet tomorrow with some more examples, and we'll leave it there.